Okay, we're still in section 12.5 about lines and planes in space, and we're on page 18 and actually example 18 as well. Here in this example, we want to find parametric equations for the line through the point P, which has coordinates -3, 2, -3, and the point Q, which has coordinates 1, -1, 4. And B, parametric equations for the line segment joining these same 2 points. So we want the entire line in part A and just the line segment joining those points in part B. So we're going to let V be the vector from P to Q. Okay, that's certainly a vector that's parallel to the line because both those points are on the line. So that's easy to figure out, right? If we let the vector be V from P to Q, then it's 1 minus a -3 or +3. 1 plus 3 is 4. -1 minus 2 is -3. And 4 minus a -3 is 7. So that's a vector V that's parallel to the line we want. And then using either one of those points, P or Q, as your point P naught with coordinates X naught, Y naught, Z naught, I'll use point P. So again, you could have a slightly different, you could use Q and it could look slightly different, but if you use P, it's going to be X equals X naught plus T times V1. So that's -3 plus 4 times T. Y equals Y naught plus T times V2. So 2 minus 3T. And Z equals Z naught plus T times V3, or -3 plus 7T. And then T, we can either assume it, but in this case, since we're dealing with parts A and B, I'll write it. T goes from -infinity to infinity. In part B, simply by using the vector V from P to Q, if we let T equal 0, then we're at P. And if we let T equals 1, then we're at Q. So it's simply the same parametric equations. It's just that T is now between 0 and -1. I'm sorry, 0 and 1. If you had chosen Q as your initial point in part A, that would go from -1 to 0. Okay. Something that's usually we might need to do at different times is find a distance from a point S to a line. Again, to a line that's through a point P and parallel to V. So in other words, here's the picture. So here's our line L, which is through this point P. It's also parallel to a known vector V. And I want this point S that's not on the line. I want to know the distance. Now the distance from the point to the line is this perpendicular distance. Okay. So if I look at this triangle, if I think of the vector PS and this vector D, or not the vector D, but the length D here, this triangle, the sine of the angle theta, which is the angle between the vector PS and the vector V, which is parallel to L, sine of theta is D over the length of PS. In other words, D is the length of PS, the vector PS times the sine of theta. So there's D. Now, if I just add in the length of V in the numerator and divide by the length of V, so it's really the same thing. You can see these would cancel out. Then I have a nice formula for that distance. It's the length of the vector PS cross V divided by the length of V. So, for example, find the distance from the point. And the reason that formula is important, by the way, is I don't have to worry about the angle theta between the vectors, right? I just do the mechanics of this. So example 19, let's find the distance from the point S, which has coordinates 1, 1, 5, to the line L, which is given by these parametric equations. So we can quickly find the vector that's parallel to the line, right? It's the scalar components here that are multiplied times t in each one. So it's 1, -1, and 2. That's the vector V that's parallel to the line. Choose, I don't know where I wrote and. Choose any point on the line for P. The easiest is to let T equal 0, because that just gives you the X naught, Y naught, Z naught, right? So that's your point P. So P would be 1, 3, 0. So that means if I look at S, which has coordinates 1, 1, 5, the vector PS then, take the coordinates of S and subtract the coordinates of P, right? So 1 minus 1 is 0, 1 minus 3 is -2, and 5 minus 0 is 5. So this is the vector PS. So now I can figure out mechanically, right? PS cross V is the vector 1, 5, 2, And then the distance is the length of PS cross V divided by the length of V. So that's square root of 1 squared plus 5 squared plus 2 squared for the length of PS cross V. The length of V is 1 squared plus or minus 1 squared plus 2 squared. Ends up simplifying to the square root of 5 units. So that point S is the distance of the square root of 5 units from the line L.